Hi, and welcome to Ecology. This is chapter 34, and it's on the biosphere. I'm going to try to keep this short. It's not a ton in chapter 34, and so we'll see how well I do. Let me go back to this, actually. Ecology has been around for a long time, but it was fundamentally changed in the 1960s, and I think two things could account for that. And the first one is right here in this picture. This picture right here doesn't seem like a big deal to you, but it was a big deal to the people on our planet because this was taken by the Apollo 11 astronauts when they landed on the moon. And it was the first time that we could actually look back and look at the Earth, and we realized that, wow, this is like a ball in space that has a finite amount of resources. And so, again, it fundamentally changed the way people thought about the Earth, and they started to maybe take it a little bit more seriously. The other thing that happened in the 1960s was the publishing of the book Silent Spring by Rachel Carson. This is Rachel Carson over here. She got her master's degree in marine biology and wrote some books on that. Worked for the U.S. Fish and Wildlife, if I remember right. But then eventually became an author and published this book in the 1960s. And what it did is documented DDT use. And so this is a advertisement. This is from the chemical industry, and it's essentially talking about how DDT is good for me. In other words, it's good for our food. We can feed it to our babies. We can put it on our steak. We can do whatever, and it's going to be good for us. And what she documented is that DDT is going to bioaccumulate. In other words, it's not that big a deal on one mosquito or one little aquatic insect, but it's going to bioaccumulate, and it's eventually going to build up to the point where, like a bald eagle, its eggs are going to crack when the bird sits on it because of so much DDT that's built up inside it. And so essentially what these two things just showed humans is that they have some direct consequences in whoa, did you see that? This is Bebekpo. If we say, what is Bebekpo? Bebekpo is just another mnemonic device that I use. It's a way to remember some important things in ecology. And this is a way to remember some of the ways or the levels of structure that we have inside of ecology. If we start with the first one, we're going to start kind of backwards. We're going to start with the O, and this is one flower. And so this would be considered an organism. And so one living individual, and that could be a bacteria or it could be you, would be an organism. The next group then, if we have a bunch of those living in an area at the same time, we call that a population. Remember, we talked about that earlier when we were talking about gene pools. We then have a community. Community, you can see that flower has gotten some company. And so all the animals that accompany that flower, or we could think about all the living things, like we've got some butterflies here. All the living things in an area are going to be the community. We could then take it to another level. And so again, there's a slight change here. What have we added in this diagram? Well, now we got clouds, and we got water, and we got puddle here, and we've got abiotic things. In other words, we have things in the area that are not alive. And so that combination of everything that's alive, everything that's not alive but contributes to that life is going to be called an ecosystem. So hopefully you're figuring out why we call it Bebekpo. Finally, we move to what's called a biome. A biome is going to be an area that has all of those things, but it's also going to have to characteristic climate, and climate is usually controlled by two things. That's going to be the average temperature and also the average precipitation throughout the year. And we can display that on something called the climograph. And then finally, we get to the biosphere. And so what is the biosphere? The biosphere is going to be everywhere on our planet where life exists. And that's going to go deep down in the soil. It's going to go way up in the atmosphere. And so pretty much on our planet, if we ever find water, in other words, if we ever find something like this, we find life inside of it. Again, you heard me mention this a second ago, but remember abiotic and biotic. What that means is abiotic is going to be everything that doesn't contribute to life, that's not living. Biotic then in this picture would be all of these fish and the corals and the anemones. But the abiotic factors are going to be like the phosphate levels, the pH of the water. It's going to be the chemistry. It's going to be temperature, all those things that are going to contribute to that ecosystem. Climate's a big word. Climate, remember, is not weather, but what is climate? Climate's going to be the average temperature and precipitation for an area over a long period of time. Now we know why we have seasons, or at least we think we know we have seasons. In other words, the Earth is tilted towards the sun during the summer, and then as it orbits around the sun, it's actually tilted away from it. But how does that contribute to our temperatures? Well, I love this diagram here, because if you look at it, here we have a sunbeam that is traveling towards the Earth, and it has a specific size to it. And as it hits the Earth, if it hits the Earth right here near the equator, it's all going to be concentrated in that small area. But if we look at that same sunbeam a little bit higher, it's going to be spread over a larger area. Or if we look a little higher than that, it's even going to be spread over an even larger area. And that's why it's generally going to be warmer as we're near the latitude. And so we can see that clear change as we move up in latitude. What else affects it? Well, the Earth is not just tilted, but the Earth is spinning. And as it spins, everything that sits on top of it, and the two things I'm mostly concerned with are the atmosphere and then the ocean. Everything that sits on side of that, on top of it, is going to start to spin as well. And we call that a Coriolis effect. And so what you get, and you can see this on a weather report, is we get spinning in this direction in the northern and this direction in the southern hemisphere. And that's caused just by the spinning of the Earth. What does that cause? It causes orbits. Like this is an orbit that creates, currents that create, for example, this is the Gulf Stream that delivers that warm water all the way up to Europe. Another thing that can affect climate is going to be mountains. If I put a mountain right here, and the wind is moving in this direction, as that weather moves up, or as that air moves up and over the mountains, it gets cooled, and eventually it gets cooled to the point where it drops that moisture as precipitation. And so usually on the windward side, we're going to see a lot more precipitation. And then on the other side, as that air starts to drop down again, it's dropped its water off, it's actually getting warmer, and so we have what's called a rain shadow. Now, one thing I really want you to know about climates is that climates are averages. And so today is April 23rd. And April 23rd in Montana looks like this. This is a picture that's taken out my back window. Now, if we were to look just a few days ago, it would have been green grass and it would have been a sunny day. And so what is climate? It's not this picture. This picture is weather. It's what it's like today. Climate's going to be what it does over the long haul. And it's hard to make predictions about what's happening in the climate because there's so many variabilities. But let's take a look at some of the biomes then. Biomes, again, are large in that ecological classification. These are going to be larger classifications. They've got living, non-living, but the characteristic kind of temperatures and precipitation as well. So start in the oceans. What dominates in the oceans? Well, the area of light is going to be what's dominant. In other words, wherever we have light, then phytoplankton or tiny little organisms that can do photosynthesis are going to generate energy from that, and then they're going to be fed on by zooplankton. Now, if we look way down here into, like, for example, these are going to be the benthos, really deep down in the ocean. There's no photosynthesis going on, and so everything down here has to survive on material that's made up here and has died and has drifted its way down. A couple of other terms in aquatic biomes. This would be a wetland. It's a combination of an area where terrestrial meets the water, aquatic environment. This would be an estuary. It's another real fertile biome. It's an area where the fresh water is flowing out into the ocean, and so salt marshes form these really nice boundaries between the ocean and land. This would be freshwater. This is the Yellowstone River in Montana, and so it's an example of a freshwater environment. And depending on the speed of the water and the temperature of the water, you have totally different animals that are able to live there. Now, if we were to plug all those things about climate in, what we would end up with, if we were to look at the map of the world, we would find that we're going to have these characteristic areas called biomes. And biomes are going to be areas where the average kind of remains the same. So we've got things that you're probably familiar with, like tropical forests, savannas, and deserts, but then some things that are new, like a chaparral. So let's talk about a few of these really quickly. This would be a rainforest. Rainforests are going to have a huge amount of precipitation, and they're dominated by trees and a canopy. This would be a savanna, like in Africa. They're going to have seasonal rains, and then they're going to have times where there's not so much water. This would be a desert. Desert, remember what dominates that is going to be a lack of water. This is a new one. This would be called a chaparral. Chaparral is like a woodland and shrubland. Example of this would be California, or if we were to walk around Spain, it's going to be kind of a chaparral. And this would be grassland, so like the Great Plains. This would be a broadleaf forest, like you might have on the East Coast. And this would be a taiga, and that's going to be a northern coniferous forest. And then finally we have a tundra.